It'll be close. We'll see how much of this we cover. All right, somebody see if it's streaming. Because a couple of times I tried to stream, I was streaming and it said that it didn't go through. So somebody try to go to it, see if this particular, the 20th is streaming.
Looks to be working.
You see it?
Look at that.
You see the class?
Yeah.
Huh? All right. So if it ain't working, blame Mr. Who? Okay. All right. So we went through modules, and then I'm gonna get in. Then we're gonna start talking about what Miss. And this is where we stopped on the different hierarchies. All right. Okay. All right. So Miss James, she asked, why do we use void on those modules? Okay. The reason being is that right now we just write simple function. Okay. We're not passing any variables, meaning taking a value from one function and sending it to another one. But the main thing is we're not returning a value. So that void, when you look at a function and it has void in the front, you know that you're not returning some type of result. Okay? Normally what happens is you write a function and that function might compute a value, all right? And that value is local to just that function. In order for you to take that value and use it, you would have to return it. Now, let me ask you this question. If I had a value that was 5.3 and I wanted to return 5.3 once I execute that return back to that function, and I want to return that 5.3, what would be in front of my function name? No. Okay, void gives the data type of the return value. So 5.3 is of what data type? Float or double. You see what I'm saying? So if that was the case where I was returning a decimal value back after I executed, I would have double or float, depending on the size, double the function name and whatever.
So what would happen if you put float?
Well, remember the size of the value. I mean, right, remember? That's the only.
It returns, right? It doesn't return the void though, right?
Well, yeah, void is like nothing. It's like you look in space, it's void, that means empty and nothing.
Well, like I'm saying, if you put float, it wouldn't change that? It wouldn't return?
Well, but see, you gotta understand when you write in code, if I put a variable, if I put a data type, it's expecting a return command with a value. So you can't just say int whatever and just like in main we got return 0. Well, the main is kind of like the only one that's somewhat, but all the others, when I have int show value, it should return an integer value. Now let me ask you this. Now we kind of looked at it. If I had say get letter, well say int get letter, all right? Stay with me. Int get letter. Then in that function I say char let equals a, right?
Okay.
Then I'll say return a.
Okay.
But then it's like, well, what will I be returning? If I had int get letter. When I define my function, it'll be int get letter. What will it return?
Be the A, right? Let?
But int,
Whatever variable that A is going to represent.
but A is a char value, and I'm passing back an int value, so it's gonna take what? Remember in the first chapter? It's gonna take A, the letter, and convert it to what? The int value of A, which is bam.
Yeah.
Now you understand what's happening.
Yeah.
Right. So
What does char option mean?
char, a single character.
I know what that means, but I mean, I've seen before where they say char option.
In this chapter. I'm not understanding.
Get out of the class.
See, char option. I'm not understanding. It's a command.
I saw it on one of those programs when you're doing like temperature, like Celsius and Fahrenheit, and
But see, depending, option might have been some. No, I can't say it's a function. But char, and it
it
said
just confused me. 'Cause I thought char can only be assigned one letter. So,
right.
right, but it say in the program it said char option.
Char equal option. No, but see, char option semicolon.
Yeah, that's it.
What they doing there, class? When you say char, if I write this, come on, you're not thinking now. If I write this,
Char option mean it's optional? Like,
no, if I do this, like that what you talking about?
Yeah.
Okay, if I do this.
So option's the variable, right?
Ah, that's all it
But
is.
what I'm saying, I thought it could only be one letter.
No, the value that it holds can only be. Oh, now you got it. See, option can equal to.
Oh, I get it.
You got it?
Gotcha.
It can equal to the letter A, but option is what? A char variable. The name could be as long as you want it to be. You understand?
Right.
Well, they
You couldn't
said
do that,
basic.
could you, though? You have to write char option, then semicolon, then under it put option equals A.
Now, what you would do, you would be declaring, then you would be assigning. Right. But that what he was saying. He just saw char option. Right.
Well, I just didn't know if there was like a specific thing with just char option to where you don't.
And you like me saying char, fucking right. Char letter. Letter is what? More than one character, but that's the what? That's the identifier, the variable. Right? But it can only equal to one character, no matter what it is.
Now let's say you ask the user to put input into it, and the value is more than.
It's gonna just pull, it'll just pull that, remember? It'll just pull the first one. Remember when we had the examples where and I think, was that this class? I don't think it's this class, but it's 193, where you had an int, you input an int, you input a float, and then you input a character. All right? And I'll kind of run through that right quick with you, but I don't want to confuse you. That's in the next chapter. But, in the next level, but you can still kind of understand it. If I had something like this, int x float, I'll just say y, and char z, right? Mm-hmm. Now, I could do something like this, right? Cn x y z. I could do that, right? Now, what is expected here? What for me to input? What type data?
A whole number.
All right. What type data is expected here?
That could be all decimal.
All right. And what type data?
One character.
All right. So if I do that, everything gonna work fine. Won't have any issues. But say when I input in the book in that chapter do 5.7 and like say the number 4 and then say the letter B. I type that in, right? When I hit enter, what's gonna be stored in X?
5.7. No,
5,
no,
What?
it can't be.
just 5.
So what?
Just 5.
Just 5, right, Mr. Sturdy? Just 5. What's gonna be stored in the Y?
4.
4.0. 4.0.
Huh?
4.
What happened to the 0.7?
That's not, so it's not there.
No, it ain't. Listen, what happens when you input data, I'm gonna kind of do it like this. Say you have a cabinet, in a sense, which is your keyboard buffer. So in the cabinet, I'm putting 5.7 space. I put a backslash there. 4 space. Yeah, that's right. Space and B. That's what's in the keyboard buffer. So what happens is it's gonna take the 5 because the 5 is the integer.
So 7.
Now it'll throw it away in the sense that it won't use it, but that it stopped reading here. Then it's gonna pick up at the what? 0.7 because you say, hey, this is a float. 0.7 is float.
So it's gonna assign itself to the Y?
Yeah, 0.7.
So then where's the 4 go?
0.7.
Then the 4 goes into Z.
Where did the B go?
B gonna go for the next input if you do have one, whatever it is. So you see how your data is all thrown off?
Yeah.
So that's why it's important when you start writing your code to match your input with your statements that
Well, you
you
can also just change the into flow.
Wait, it wouldn't
Again, right?
even, it wouldn't take 0.7
You
for
can just
float
change it to
Y.
flow X.
Huh?
It takes 0.0 for float Y. It's taking that one character space.
No,
Like,
what?
that point.
For what? For Y?
Yeah,
Y is float.
exactly, but it will only take, because it's allowing only one character space.
It's gonna read up to the blank space. What you mean? For float is a number.
Okay.
That's it, a
Then
number.
it would take 0.7 for it.
Not 4, because you got a space in between the 4 and the 7.
Okay.
You see? So it stops at
There's no
the.
space between the 5 and the 0.7, so why would it?
Why you don't have a space between 5.7?
That's why, yeah, I just said that.
Right. So what happens? It says, okay, I'm gonna take this, which is integer. I'm gonna leave this alone because it's decimal. But this is still in the buffer. The read point is where? Here. Right?
You're saying that because the int's only gonna take the whole number.
I'm surprised it wouldn't give an error though.
No, because they are numbers. 5 is a number. 0.7 is a number.
7 still a flow.
Yeah, it's still a number.
Yeah, but
And 4 is any character can be a big char.
But you can also just change int X to float X, right? I mean,
Well, right, you can do that, and then it'll pull in 5.7. But what I'm saying is, you got to know that and understand when you're writing your code
that's a logical error.
what it is. Well, yes, correct.
Kind of.
Yeah, correct. Now, because like I said, it's gonna read in this. If you're in a loop, the next time it's gonna read B for X. You know, if you come back and try to read that same thing, you understand? So you got to be very, very careful, right?
Yep.
Your thinking skills got to come into play, because you can start coding and be really, really, really like, man, I don't know what's going on, all right? Everybody understand that? We got that void out the way. Well, let's do this then. Let's look at a function that has an int, returning an int, all right? So you can actually kind of see what I'm talking about, all right? Because we're doing a return 0 for main, but you still ain't really kind of seeing what's happening because that's just that function. So let's look at online GDB. So we'll create a program in online GDB, all right? All right. So we take this out. Right? Int main, and you begin And now, and what I was talking about with int main, some compilers you don't need to put the return 0 if you do int main. Some compilers you do, you will get an error. You understand? Because you said int and you would have to return. So let's create a function. Let's say we're gonna just say call it test. We'll say void. We'll just do a void. All right, test. Now, if I do void test, and I'll call test. All right. Now, I'll do void. Or I'll call it test average. I'll call it that. Kind of make it there. All right. So we won't do our input. We'll just give it some values. Okay. All right. If I do void. So if I do int t1 equals 90, t2 equals 80, and t3 is equal to 100. All right. All right. So now I can say what? I'll do. I'm not going to say n average equals, but n average.
You gotta change the variable inside your function. Inside the main.
Oh yeah, my call function. You're right. Yep. Now, average is equal to what? T1 plus T2 plus T3, all divided by 3, right? Now, so, and now here I can do what? See out. All right, so everybody somewhat understand this logic, right? Yeah. What we're gonna do is we declare did a prototype declaring the function that we use. So this name is now valid to use, right? So when we start our main, we're gonna call this test function, correct? So what that means is gonna go down here, go to this test function, it's void. What that means, we're not returning anything back to what? Back to the main function to be used. Because what? If I try to use test T1, T2, or average, it's gonna give me an error. Because they what? The scope of those variables are what? Local to what? To what function?
Test average.
Test average function. That's the only place you know where those T1 whatever is, based on this. Now, and the values. So I could run this. All right, and I'll get an answer. Did I do the CL? Let's say expected after void. Let's see. Error expected them before void. Let's see here. 0 void here.
Set the using namespace at the top. You would have sent code. All the way to the top.
Oh, using namespace. All right. So now let's run it. All right. Oh, I still got an error. Redeclarate. Okay. In line 9. No, I'm calling it here. Void test average. Test average. And test average. AVE or HE. Let's say redeclaration of int. Oh, let's see what I did. Int. No, I put in here. See, I could have done it this way, and that's what I was telling you. I could take this out and do int average equals and that, or I could just say int average and then do an assignment statement. You got me? All right, I'll do that, and this is just my assignment statement. All right. So what I had, I'm trying to declare it multiple times. That's an error, right? Right, Klein? Nobody see that. So now, when I run it, still give me what is token broken? Oh, boy, what's going on? All right, running. Okay. So now my average is what? 90. Where was printed out from? What function? From what function? It's printed here.
Oh, from the board.
From test average, right? From test average is the function. If I were to take this statement here and cut it and go in here and paste it. Everybody saw what I did. Test average. What test average gonna do? Test average, we're gonna go here, we're gonna say, okay, test 1 is 90, test 2 is 80, test 3 is 100. Okay, in average. Then average is equal to T1 plus T2 plus T3 all divided by 3, right? And we did get an average in this function, correct? But then we didn't print it out, right? But we went back to the main function and say, okay, after I run my test average function, give me my average. What's gonna happen here? Huh?
The same thing.
Remember the scope? Remember the scope. Remember what I said. If this variable is declared within this function, where's the scope of it? Just in that function. The rest of the program does not know what that variable is. Right, class? Everybody got me on that. That means, looking at that, test 1, test 2, test 3, and average are local to what function?
Test average.
Test average function. That's the only way it's recognized. All right? So, if I wanted to print the average, and Miss James, we still on you now. I'm just showing you, I'm building it up. Now, if I wanted to print the average in the main, that's a different way of code. And sometimes I might give you a program. I'll say, well, LB 193, maybe this one. Write a program that will retrieve and calculate the average of so many test scores from within a function outside of the main, but then print the average in the main function, right? So that means, that sounds like I'm gonna have to return that value. You got me? Now, if I tell you to use global variables, then what? It don't really matter, right? Because once I put a variable, declare a variable above the main, it's global and I can use it when? Anytime I want, everywhere I want. Yes, sir.
So, okay. Wait, so the reason you put void test average above the main function, like I don't.
I'm just declaring that I'm gonna use a function. That's a prototype. I'm saying this is gonna be my prototype of my function. Void, which means I'm not returning anything. Test average, which is the name, and no argument list. And then I gotta go down here.
So anytime you have a function that isn't the main, you have to establish it in the global.
Well, right. And like I said, yeah, your functions have to be declared. Yeah, right. Right. Now, look at this. In order for me to print that test average, I need to change up my program. Check this out, Miss James. Watch this. Watch what I'm gonna do. I'm gonna go here. I'm gonna say int. Oh, I'm gonna say int test average.
What would it return at that point?
It ain't returning anything until I program it to do it, until I write the code. But now I have the what? Ability to return. You got me? So now, this can stay the same here, all right? Here I have to make this equal to my prototype, right? Right, has to be int. Now, in here, I have an average, so what I want to return?
Average.
Right. Everybody understand that? I'm not returning 90. Well, I am returning the value 90, but you really don't know what it is until the program executes. So I'm returning the value of average. So here I'm gonna say return. All right, return average. Now, when I return, where I'm returning back to?
The main.
To the main, basically. Basically, in this program, we return it back to the main, right? Now, that's why it's important for you to understand the hierarchy of those functions. What function is calling what function, right? Because if another function was calling this average, then I couldn't just print it in the main. You understand what I'm saying? So that's one of the differences. Yes, sir.
So the hierarchy chart is like almost like an outline to a paper.
Of what function is being called when, by what?
Just to break it down to simpler.
That's right. Well, you can look at it and say, I don't know the code, but I know that from the main is calling this, and this. Okay, but this function that is calling, this function actually calls this and this.
Yeah,
So
you can't do all that in your head. I mean,
right. And then, like I said, when you have see, this is what a lot of students don't understand, and I could get it, but many times when you're working on a project, you have to present your argument as to why you went about doing it a certain way to an audience or to the boss or to a team. If you understand what
or something, yeah.
Right. And then in looking at it, they might say, oh, well, what if we don't call it from this one, but we call it through here and do this? So, and that way you can better discuss and try to get it tightly knitted and do what you need to do. Because you're going to have to present. And like I said, you know how to do those different charts. That saves a whole lot of time than trying to explain, well, I have a function that's calling this, and then this that's calling this. Hey, this is a hierarchy chart. This chart shows what task that's being performed in each individual one, and when I call one, this is what happens, and it has to return back.
Right. Do you know any application software that can actually have the outline of the flowchart for you already?
No, because every flowchart can be different.
But how do you design it in an application? So like in a
No. You use like Microsoft Word or some.
How would you do that though?
In Word?
Yeah.
All right, I'll show y'all this after I answer this question. All right, so we had gotten that error, and now I'm getting it a return. So now I'm returning average, right? Now check this out, class. Now, I'm returning a value. That value is being returned based upon the execution of what? Test average, right? So look what I'm gonna do here. I'll say int AVG is equal to what I've just done. I created a variable called what? AVG,
Right.
which is gonna be assigned what?
To average.
No, right. It's gonna be assigned the value of average, because I'm telling it whatever the return or results of the function, store it in average.
Right.
Now when I do that, now I can do what? Still can't print average, right?
Right.
Unless I would have said int average equal. And then but I'm just changing the name so you can see. Because average in this function and average in the other function is two different variables, right? Everybody understand it? But I'm gonna use AVG just so you can see. All right? So now, let's run it now. Bam. You got me? Now, Miss James, did I answer your question?
Yeah.
All right, but you understand why if you use int, and look, let's go through it. Int test average. Looking at that, I'm gonna have to return something, right? Once I execute test average, something needs to be returned, whatever value, int value. Now, here I'm calling I'm calling test average, but whatever's returned from test average is gonna be stored in what?
Yeah.
AVG. Right? All right. So now I can't do the output yet. I have to go and execute, right? So I'll go down here. Now it says, okay, int T1 equal 90, T2 equal 80, T3 equal 100. Int average is equal to T1 plus T2 plus T3 divided by 3. Okay, I got the average, right? Now I'm gonna return the average. So when I return, this function call is equal to what? 80. So 80 will be stored into average, AVG, and now I can see out AVG.
So did you erase the C out at the bottom?
Yeah.
Oh, okay. I kept getting.
Well, I remember I cut it and pasted.
Right.
Right. Now, with, and I want to show you. Now, there's another way you can write functions. Remember the parentheses after the function, right? You got the parentheses. You say, okay, what's that? Y'all been asking, what's that, Mrs. Sylvester? That's your argument list. Now, you say, well, what you mean that's my argument list? Now, let me say that. Now, you know we could have did CN, C out, CN, C out, CN, C out, CN to actually type in the values, right? But I just wrote it this way so we can execute it quicker, right? We could expedite the time. But check this out. If I took this and I put this in here, this is no longer known where?
In test average.
In test average, right? It's no longer known. So how can I get these values into test average? Because that's why I want you to do the average.
Pass the values.
Huh?
Pass the values.
Pass the variable, all right? Now we're not there. We're passing a variable, which would be the value. So now look at this. How many test scores I have? So what? What the data type? Int, right? So now what I'm saying when I look at this, here is int test average saying that what? I'm going to return what? An int. But this says when I call test average, I'm going to send over 3 what?
Test.
3 integer values. You understand what I'm saying? So, looking at this, all right, that's just the prototype, right? Now, looking at this call function, so in here, now I need to send those values. So what I want to send when I do the call? Huh? T1,
T2, T3.
comma, T2, comma, T3, right? Now, in my function here, this has to match the prototype. So now I need to do what here?
3 ints.
But I need to introduce my variables because I'm in a different scope. Huh? I can do T1, T2, T3, or I can do any variable because this is a new scope. Everybody see that? So I could say, but I have to give the data type now because I'm in a new scope. So what? Int, I could say B1, all right? And I'm gonna just change it. But you could use the same name because it's different scope. B1, int, B2, int, B3, right? So now, what happens here when we call, let me make this bigger right quick. When we call this function, test average, we pass a T1 to what?
B1.
To B1. So we taking 90, which is equal to T1, right?
Yeah.
And passing 90 into
B1.
B1. We passing 80, which is T2, into B2. We taking 100 and passing 100 to B3. So you
have to change the average towards B1 plus B2 plus B3.
right, correct, because that's a new scope, man.
I said, that just seems extra though. Like the
No, but what that does though, it allows for, and I normally say a tighter program. And when I say tighter, it'll eliminate you from making certain mistakes in the program. Because if you have one large program, and like I say, all your variables are local to that main function, you could have 100 lines of code or 1,000 lines of code. You have a value up here on line 10, and it's equal to say 5. And then you have an errors in your program, so down on line 200, well, let me change it to this. You can't do that when you do this.
Right.
You understand?
It's meant for like correcting your mistakes.
Correct. It kind of protects you from making changes.
Instead of erasing your whole code and doing your code all over again, you just fix it.
That's right. Yes, sir.
So when you do this, as a function, and you actually describe what, after you declare average, you say average is equal to, you have a choice between saying it's equal to T1, T2, or T3, or B1, B2.
Up here?
Exactly. Or can you only use B1, B2, B3? I'm talking
What, right here, down here?
the last function. Yes.
No, I could, that could be any variable name because that's a new scope.
Yeah, so what's the point of declaring it as being, it can also be B1, B2?
Right. It could be T1, yeah, any name. Because what could happen, and then I normally tell students, sometimes you may want to change the name of the, okay, say like this. You may want to, in the main program, you have T1, T2, T3. This is test average function. You might have test, TA, T1, whereas test average, T1. Test average, because you might have another function and you might have calculate something T1, calculate whatever T2. So you know if you got an error, you know what function it giving it to you. Because if you name everything T1, then you get an error. Normally it give you your page number, your line number, but you might overlook that and look at T1 and you in the wrong section for the T1. You got what I'm saying?
This is coding philosophy. You're saying for every function, you have to have a different type for every variable.
You don't have to,
but
it could be to your benefit to just change the name so you know when errors occur, you know where you at and what's going on. Because a lot of times when going back and forth, you be like, man, I done changed something that was already right. I meant to go here. Right, so.
And it's gonna get so complicated when you add like if then and
deeper you get, right, deeper you get, correct. So.
And then you're asking the user to do input too, I mean.
Correct, I could be asking them to do input, yeah, all that. So now, the only variables that are known in test average is what? In this function, what are the only variables that are known?
B1, B2, and B3.
That's it. T1 is invalid now, right? I have to change T1 to what?
B1.
B1. I have to change T2 to what? B2. I have to change T3 to B3, right?
When in average change or no?
No, because it's there. Now I could change it if I want to, but that's declared where? In the scope. You understand? Yeah, see, that's in the scope already. When I said int, I'm introducing it. Right. So, but it can be any name, right? It can be any name. Now, so it's gonna find the average. It's gonna pass all those three variables, find the average, and then return what? Average into AVG, and give you it. All right. So let's run it. See? Right? So that's where we're gonna be trying to head to. But this 192, we're not gonna do a lot of it, but it's good to know, and it's good to start trying to program that way, because this is the way you should try to.
Have any assignments like that we can do? Or?
I might get one or so, but that's a little advanced, for like this. But it's good to know.
What about like practice assignments?
Yeah, I could do that. Yeah. Right. But it's fun, man. Like I say, and then if you understand what, okay, int. Okay, here my call, I'm passing my variable in my call. But then in here, I'm doing int, introducing a new variable. Int, introducing a new variable. Int, introducing a new variable. And then int here, it's been created in here, and then I'm finding the average and returning that average. And this C out will put it in AVG, and then the C out, I can see out the AVG. Right? So the parameters, that's what that was those parentheses are for, passing arguments. Now, can I use just int data types? No, it can be anything. And like I say, sometimes you might be reading data from a file, and just like when we had 5.7, whatever, I could say float int char. Now what does that mean? What that says here? When I have float, int, and char here, when I'm calling this function, what should I be passing?
A decimal, and then just an integer, and then just one character.
Correct. Or a variable that's float, int, and char.
Right.
Everybody see that? Right?
Yep.
And then down here, hopefully, like I say, starting the program now, you should have what? Float, whatever. Int, whatever. Char, whatever. So it should match your prototype. Right? Everybody understand that? Okay. So that was answering your question about the return. Yeah, you got
Like the int test average, you're gonna have to change that at all.
Right here. Where at?
In front of the float int char.
Right here? This one?
At the very top, like right above.
This?
Yeah.
Well, I did. I got float. You talking about float int char?
But you
The
call it
beforehand.
the int test average.
So will that change it all or no? Just
So-
What is in
It's
here?
gonna take those values and turn
Because
it
all that int is saying whatever I do in here, I'm gonna return a what?
the first
Int value. Right. You got me? Because I can be doing something else with that char value and that float value, but whatever I do, I'm gonna return an integer value. Right?
But I'm saying it could change though if it was like a different variable.
Yeah,
If we're
yeah,
looking
yeah.
for an integer, you can look
You can look for float, you can look for char, you can look for
like
string.
string.
String? Yeah. Oh, yes. Because I could have string in here. I could say string.
Right.
If it's first name, middle name, last name, whatever, yeah. Right. Right?
Yeah.
There you go. All right. So, any other questions? Questions?
Look good.
All right. All right. And look, local variables. We kind of talked about local variables. Local variables are only known where? Within that scope, right? Outside of that scope, they're unknown. And when you're dealing with functions, you need to understand that. And that's when, like I said, you may have to return a value, all right? Return that value. Now, there's something else called passing by reference, all right? And we don't need to deal with that. But what that does, that actually passes the actual value, not the actual variable
Right.
value. Right. It'll pass it by the address.
Gotcha.
Yeah. Okay. So that's something different. All right. So local variables, and look, they say here, if I declare string a string called name in this module called getName, is it known here? No. You understand? And look at say this will cause an error because what? It was introduced, declared inside of getName, and when getName returns back to the module, it won't know what name is, right? Unless we do what? No, unless we do what? What that R word? Return it. You got me? Cause what? On this main module here, no, not the main, on the getName module, I could say what? String getName. And then what? Return name, right? And then in here, where it's saying this display name, say getName, you could say string name or string in is equal to getName. And it's gonna store it into that string variable, and then you could print it out in that CL. Alright? Alright. Now, so like I say, then let's talk about the scope and local variables. Okay? Programmers commonly use the term scope to describe the part of a program in which a variable may be accessed. Alright? So the scope is the area where it's known, where it can be used or accessed. Alright? So the variable cannot be accessed by statements that are outside of this region. Okay? This means that a local variable cannot be accessed by code that is outside the module, which we kind of been talking about. All right? Or inside the module, but before the variable is declared. Right? So what? I have to have something declared before I can use it. if I tried to do average is equal to T1 plus T2 plus T3 divided by 3 before I do int average, I have an error, correct.
Just like when you do it in the main, it'll be the same way.
Correct, same thing. You got to declare before you try to use it, all right? So that's basically what they're saying. So, duplicate names, it can be done. In most programming languages, you cannot have two variables with the same name in the same scope. Right, in the same scope, right. For example, look at the following, all right? So here we got, right here, where declare int age. But then look, declare integer age. Can't do that. Because what? That's just like me going here, and here I got int T1, then I say int T1, all right? It's already declared, so I cannot try to reintroduce it to the compiler, all right? So it's already declared, all right? So that's what it's saying. All right, now, it has to be unique. Now, but remember, we talking about the scope, it can be in a different scope, right? Because did I do it with the T1? I did it the first time, and it worked, right? And it worked. And then I could even do the average. Because if I go here, and I say, make this average, and make this average, the program will still work because what? Averaging this scope is different from what? Averaging this scope. You got me? Two different scopes. And what? I'm passing the value back here, which happen to be passed back into what? A variable called average, but the scope of that one is in the main, right? So I could run it, and it should still give me what? Let's see. Complicated, let's see. Remember I changed float, whatever?
Yeah.
Yeah, I changed all this. Yeah, I changed this.
Wouldn't it be smarter though to change it so it's easier to kind of go through it if you
What?
went back on it?
What's that?
If you actually went back and changed the variable.
The data type?
Yeah, instead of like using the same variable from two different scopes, wouldn't it be better to use two different variables for different scopes?
Have two different ones?
Yeah.
Like,
But that would I would say
names all together.
Yeah, it wouldn't be
Like,
like
you do better
use-
not to repeat a name even.
right, because you can keep track of where you're using that name.
It's like good practice.
Right, that's what I was saying. But at the same time, well, because they're gonna be different variables. You understand?
Yeah.
Because they're in different scopes. So I would say use a different name because what? You can get confused and you look and you might change one letter. And then all of a sudden you change something.
It's hard to read.
Right. Correct. All right. So you see it work with averaging both places, but it did what? Depending on what? The scope. All right? Okay. All right. So that's dealing with scope. We did it. Passing arguments. We went over passing arguments, right? And we did the program where we did the prototype, the call, and definition. And if you can kind of understand coding based upon what is needed, man, you'll get it. Say like with the functions, you know you need a prototype, right? That's like declaring it. You're gonna have to have a call. Now, if you got something like int whatever, your call might have int. Int x equals, and it's gonna equal to that return value. And then in your definition, you're gonna have the header of that function gonna be like your prototype, but you're gonna have to give the data type and the variable, and then define what you're gonna be doing, and then return with it. All right. So like I say, just kind of work with it, and you'll catch on to it, and then the rest of the classes, will be not, I wouldn't say easy, but they'll be a whole lot easier because you're not trying to learn while you're in the class. It's like, man, I got it. I got this part. All I'm got to work on is the logic and whatever was introduced new. Okay. All right. So passing arguments, like I say, you pass variables or values or by reference, or you can pass them by the value. All right. So what we showed you how we passed T1, T2, and T3 to a function, executed this assignment statement, printed out the average. Then we did the same thing when we passed the value. We passed the values, returned the value back. Yeah, and then we printed it out because they're gonna talk about returning values too. So like I said, that's passing variables. Now look, they actually pass what here? A number. You can do that. Watch in the program, but that would be a dinosaur thing to do. You understand? If I did this, pass 50, 20, and 90. That would be valid, right? But if I had a program where I had a loop and you had to input the scores, every time it runs through here, it's going to what? Pass 50, 20, and 90.
Right.
But with a variable, it'll pass those values that variable is equal to. So that's
what I don't like, because it's like not application. You know, not using
Right. It's kind of like running the program and you get the exact same answer over and over and over and over again. Right.
What if you're dealing with percentages?
What about it?
What would be like, it's not like a
float. I'll be floating.
Okay.
So see here, got the answer. But I'm gonna get that answer every single time. Just like with the other one. But I could do it where I can do the input, but I'd have to change just to the variable in order to get the different outputs each time. Alright? Yeah, but if it was percentages, if I had to select 0.5 or 0.75, that's float or double. Right. Because I could change this and say float, right? I want to return, well, let's go back up here. I'll say float. All right? All right, float. Got these values. T1, T2, T3. All right? Then we go down here. If I pass back an int, it's gonna pass back what? Just the whole number and no decimal, right? So float. All right. All right. So now I can do this. And now my answer should come out if it's not to the or whatever as with a decimal place. So let's see here. Oh, still what? I got an int here, right? So whatever I return is still being assigned back into what? An int, right? So, and sometimes that could be a headache because oh man, I changed everything and whatever. And then just a one little word int right there could be the problem. All right? So if it's not exactly, let's say, 80. Normally a 3 will change something. Still not in one something. Flow. No, but that should work. That should have ran. Must be even. I tell you what. Well. Still might be home. What? Trying to fix this thing. There we go. So the number's coming out to that whole number. Alright? And remember, if I put in here, well, not here. Yeah, if I make this int, it's returning it back into an int value. So that way, here it's gonna be 79. See? Right. Because if I said int, this is equal to this. Alright? And then there's ways you can force the decimal place if you want to. Like this one, if it came out to just exactly 79, You can make it 79.0, 79.00. Yes.
But if you do have a small logic area in your program, and your program is like 225.
You just gotta go through it.
You gotta go through the whole thing.
Now the best thing I say for that is diligently try to find the error. But do not, how would I say it? In a sense, do not say, okay, man, I'm gonna work on this, I'm gonna find it. And you work like 3-4 hours constantly. Cause what happening is you read through it, you wrote the code, and what you're doing is you're really overlooking stuff. You think you're reading character for character, but it's like you know what you wrote.
Almost like proofreading your own paper.
Right.
Basically.
So you gotta put it away. Take a nap, wait till the next day, and then go back and start and 9 times out of 10 you go, man, why? You know what I'm saying? That it happens. Cause now you're looking character for character, what happened, and then like, oh well man, it's right here. Yeah, it happens. And I tell you, sometimes you can have you be writing code, and just an example, and your little brother or cousin or somebody, you writing code, you frustrated, and then what's wrong? I'm writing this code, whatever. Well, how it's supposed to work? And you start explaining to them, this supposed to this. Well, what's this right here? They start pointing out stuff, and you're like, oh, I see, I did this. Because they don't really know, but it's like you done explain something to them, and they trying to go through it and decipher, and it's like they pointing to something that I thought was obvious. Then you looked over it, right? So sometimes that happens.
It's like you'd rather have a syntax error than a logic.
Correct, definitely. But that's why it's best to write down your flow chart or pseudocode, so you'll have a guide as to, okay, I'm supposed to do this first, this, and do this, if this, then do this, and do that. Then you have a guide. Now, whether it's right or wrong, you don't know if your flow chart is logically wrong. But you can take that flow chart. Hey, let's look at this. Could y'all look at this with me? This is what's going on. And then somebody could say, oh, well, right here, why are you doing this to this? Oh, why would you be adding here? And so they kind of pulling out you to defend what you wrote. And then you go back, oh, I don't want to do that there. I need to do this over here. Then you move that, shuffle and whatever. So, that's just like with the IO.
Suggested like a programming, a compiler that can recognize logic errors?
Oh, no, but listen, how would I say it? Let me ask you this. If I gave you the task of writing a program that were to read in the test scores, right? And output the test scores, rounding the 100th place. Where you gonna find that logical error? You can get output in everything.
Yeah.
You understand?
Yeah.
So it's like you have to know what the program is going to be doing. It's not something that say, oh, he logically doing this, that, okay, now that. No. You understand?
They can't even have like a compiler like obvious, like 5 + 5 = 10. Like.
No, because let me ask you this. It's kind of like me saying, why would I have to take a taxi to get to Walmart if I was already at Walmart?
I get you.
You know what I'm saying? Why write a program that would whatever my logic, if it was, why write it if it was already written?
It's meaningless.
Yeah. Right. You see what I'm saying?
Say 2 + 2, but 2 × 2 is still gonna give an equal. But if you meant one and you typed the other, it doesn't know that you.
Right. The computer doesn't know that. It don't have feelings or nothing. Right. If you're like, I'm gonna do what you say. Right. That's it. Because what? Logically, it could be what? Right.
Oh.
No, what I'm saying? Logically, it could be right, but the computer doesn't know, right? If I add 2 + 2 and get 5, somewhere I'm adding 1 to it. Logically, that might be what I wanted to do, right? But if it had a program that said, no, 2 + 2 is whatever, but then the computer still have to check itself because somewhere it is adding whatever. So.
I get you. That makes sense.
Right. All right. So, Mr. Gaddis, he asked about how do we flow chart, and I'll show you. Okay, this talking about, and we looked at this. They take that value and put into what? That variable, right? In that call function, right? So now, let's look at this right quick. Arguments. We talked about arguments. All right. Parameter, variable, scope. We talked about that. Passing multiple arguments. We did pass multiple. We passed 3, right? Okay. And look, this is the first, and you have to keep them in that order if that's how you want them. Whatever order you list your variables in your call, in your main function, not here, here. Like say, take for instance here, I'm passing B1, B2, and B3, right? So excuse me. T1, T2, and T3. T1 is being passed into what?
B1.
B1. T2 is being passed into
B2.
And T3 is being passed into
B3.
B3. Now, for whatever reason, when you're doing the average, it doesn't matter the order because you're gonna collectively add all of them anyway. But sometimes you may be grabbing numbers like age, maybe a number of books read, and something else, integers, right? Or floats. But it's important for you to have that pulled into the right variable, right? So here, if I did this, T2, T3, T1, all of a sudden now, what's happening? T2 is being passed into what? B1. T3 is being passed into what?
B2.
B2. T1 is being passed into B3. And now all of a sudden, now you have a formula and all those numbers are somewhere with it. Now you got to kind of keep track in your mind. Oh, T2 is T1. Oh, T3 is T. You understand? So yeah, it's like you could get confused, right? So make sure you match up your variables in the right order that you want to read them, so that when you start manipulating them or doing whatever, you can get the right results. All right. So like I said, we went over that. That's hierarchy. So I'll be at the end of the chapter. But how much time I got? About 4 minutes. I'm gonna show you.
Yeah, 12 minutes.
All right. Okay. Okay. Yeah, that's function. One old function. All right. Fine. Yeah, that was the chart. Global. Okay, they talking about constants. Remember how do you declare a constant variable?
You put it above the main.
Or what you use in it? What's the command?
What's the command? First it's whatever data type.
No, first is what? CONST, remember? The word, the command, CONST. Like, here, if I'm gonna use a constant variable, like you said, before the main, I could say something like CONST, and then float, then I could say INT, enter is equal to 0.28. You understand? So that means interest anywhere in the program can only be what? 28, period. Nothing else.
Well, that be the same thing with tax too.
Tax, yeah. When you set that tax, if you set it as constant,
Yeah.
if you don't set it as constant, it can change in the scope, right? It can change. All right. So that's that constant. All right. And like I say, we still got some in the chat, but let me show y'all how you can do the flow chart in Word. All right. So here we have a Word document. Say we somewhat take what we was doing with just simply taking 3 numbers and adding them. All right. First of all, we need our terminal symbol, right? So you go to this is the home button. Where did I go? I went to Word on WordPad. Okay, let's go to Word. In Word. All right. Oh no, this one. Okay. All right. So in Word. Come on up. Come on. All right, so we in Word, we open up a blank document. All right, so you can set your margins, whatever. Okay, I'm gonna take that off. All right, if you wanted to, you could do margins, you could do layouts, where the margins. They got preset margins, you could choose these or whatever. Sometimes your printer, if you print it, you know, because the inkjet, the bottom of it can't go beyond 0.5 and all that stuff. All right, so now, what I'm gonna do insert, all right, and shapes. Now watch what when I click on shapes. Scroll down here, what? Flowchart symbols, right? I'll click on the terminal. I'll hover over it. Well, where's the terminal? Here, terminal symbol. And now I can click and drag, all right? By default, it'll be blue. You can change that. Right click in it, add text, and then what this would be? Start. Right? If we start. Then you need a line flow. And like I said, I can modify this to where I could change this color to whatever I want if you know how to use, something about that default color. Now, I can go to shapes here, and then I could say fill, no fill. All right? And now I just have that. So, you know, you can work with it that way. Then what I want to do, insert, go back to shapes, the arrow here, right? Just choose the arrow, and I'll draw my line. All right? Here. All right? If I wanted, then what we did, we didn't do input, but we declared our variables. All right? So say without the function, we declared our variables. So now I can go back, insert, shape, process symbol, just a rectangle, but if you go to flowchart, you click on it, and then now you can what? Make your diagram. You can move it over and up if you wanted to, always. I could click here, all right? Right click in here, add text, and I could say what? Int T1. But then when we had values of 1 equals I'll say 55, 53 equals 100. All right, and it don't have to be the syntax in here, right? You don't have to have the syntax. So we had that, and like I said, I want. Well, if we did the function, we'd have to go back here and search for this, and then we would draw this. But then I forgot my arrows. We draw this box. And then I'll choose this. I could copy this arrow. You understand? See, once you get something, you can always copy and paste it. You don't have to try to go back. So I could put my arrow here.
And then I guess you go off to the side and do your function.
Right. After you're done, you start over. Right. Yeah, you can place whatever. Right? So this was what? Test average, right? Remember? And with Word, it automatically makes this capital, you know, that's understood if you do something for me in that. So you understand? That's how you would do it. And like I say, you do whatever. Your if statements, we never did if, but we had output, input, output. We go back, insert, shape, and a parallelogram, input, output. And we'll start here, go to here, and then you choose here, copy this again, paste it. All right, and you always end with the what? All right, let's sing with sing.
You had it right.
It was Singleton?
Sterling.
Sterling. See? Always messing
No
up.
class on Tuesday, right?
Yup, now, Mighty Ground, Monday and Tuesday, we are. Yeah. All right, so and like I said, and then you end it with the then you end it, like I say, with the terminal. Yes, sir.
We are going on Wednesday though?
Yeah, Wednesday we got class. We don't have class, but you know, we got Thursday, but yeah, whatever class you got Wednesday, yeah. Right? All right.
Benefit to living in Louisiana.
Yeah, that's right, yeah. Here, and then I can copy this. All right, have a good one, man. All right, I paste that one, and this will go at the bottom. If I can ever get to the bottom. And I'll put what? Right. So that's a flow chart, right?
Thank you.
And you can do your hierarchy chart, you know. Same thing.
Same way. I think that has like bonus point potential right there. Have a big project.
I do.
I'm gonna see. Good.
I've seen.
I hear you make us.
Once you did that, I'm sure you did that solo and
You
all
think
that.
you
Yeah,
are?
it wasn't like real homework.
No, I need to
Yeah.
call home and tell them she can't go.
I'm like, did you stop anything?
So as April
April 30th,
through,
May 7th.
that's
I know.
that's fine. You had to take my test earlier. Alright. No problem. Let me pick this up. What you got?
So I was supposed to be going to Miss Hibner later?
Oh, yeah, you never went?
No, I haven't gone over there, but I did the resume.
Oh, yeah,
Did
good.
it online, all that. And I
Right, you
turned
did
it in,
that,
all
huh?
that. Yeah.
Okay, yeah. And like I said, you should be getting announcements of jobs that have been coming up.
Coming up.
Right.
And